So next up, we're going to hear from Zane and Geobio, who work at Airbnb, are going to talk about how they're using GraphQL there.
All right, you hear me? Mic's on, all that sort of good stuff? Yeah, all right. Hi, we are from Airbnb. We're going to talk a little bit about our API really at Airbnb, kind of how we found ourselves in a world that we are starting to adopt GraphQL. It's going to be a little bit of a story of really how it got here and the mobile apps that inspired our current API infrastructure and kind of the direction we're headed and the challenges we're currently seeing. So on that note, I'm Zane. I work on communications infrastructure along with Geobio here. We are the team that builds a Ruby gem at Airbnb called Graphist, which is our library for doing these things, our data access library, or data access object, DAO, if you prefer. Geobio and I both started on the mobile teams at Airbnb. I was on the iOS side, and Geobio was on the Android side about 4 years ago. So that's kind of the context we brought to it. We started there and started building API endpoints out of a need just to have them for the mobile apps, but then found ourselves quickly turned into backend developers. So that's how we stand before you today. And with that, I'll kind of hand it over to Geobio to tell a little bit more about this context.
Yeah, definitely. Airbnb started off in 2008 as a primarily desktop and web experience. However, if you think about it, the majority of Airbnb is actually an offline experience. Airbnb is not a transactional, web transactional company like Facebook or Google, where you're spending the majority of your time on the website or interacting with the website. Rather, Airbnb is a human experience. You're spending your time walking out and about, exploring the city, or meeting the host, or learning how to figure out how to use a hot tub and enjoying it. And so what that means is that people want to interact with us on the go. And so that actually makes mobile an especially important experience for Airbnb. And so in 2012, we built our first iPhone app and then followed that with an Android app. And people at that point in 2012 didn't really think of mobile as a primary technology. Rather, mobile was just another platform, and likewise with Airbnb, we actually had an entirely separate team just for mobile. And what we did was we built our own mobile-specific API, whereas web had their own separate Rails controller and all that. However, as the industry evolved, we realized that mobile was going to be the future. More and more things were moving to mobile. Users were spending more time on mobile. And what that meant for us was that we had to go mobile first. And likewise, Airbnb API became more in the forefront because it was providing the data for mobile, and it became ever more important. And so where we came from when we first created the API was that API was completely separate for mobile than it is for web. Web had its own Rails controller. But the problems it created was that there was actually completely separate code paths. There were different security things, security problems, and also the fact that if you paid on mobile, you might even get a different price. But then another thing and another big problem for us going forward was that developers had to write twice, once for web and once for mobile. And so we initially had API v1, and in 2015 we started to address this problem by creating a API that would be used by both mobile and web that would address the problems. And the thing that we created is what we call Graphist, which is the Ruby gem and API framework that we created at Airbnb. And I'll hand it off back to Zane.
Thanks. Yeah, so Graphist was actually originally called Restore. Dan here remembers our initial conversations here when we first started embarking upon this journey. Restore was an allusion to the fact that it was a REST-based API. A RESTful API, Restore, it seemed like a good idea at the time. Clearly, the name evolution reflects our evolving philosophy towards data access. But it was essentially built out of a set of needs that I'm kind of going to walk you through a little bit here. But I think the core principle that I wanted to describe here is that for us, data access is an abstraction. What I mean by that is that there is such a thing as an operation. An operation is defined as an action performed on a resource. So you can think of a RESTful world as having some sort of verb performed upon a noun. You want to update a listing, you want to create a user, you want to delete a wish list. Verbs, nouns, actions, resources, that sort of thing. But when you look at it, what you quickly start to realize is that REST, GraphQL, even just Ruby code are all syntaxes or languages to express an operation. Each of these things are just different ways of getting towards the same end. It's the same operation at the end of the day. So what we wanted to build, or what we found ourselves building just out of sheer accident, I suppose, is this abstract notion of an operation, of a data access object. And REST was the syntax that made sense at the time, but we realized that GraphQL could just be another portal into that world. So the same framework that we had been building for over years actually became the groundwork that very smoothly transitioned into a GraphQL first approach. In other words, we don't have a translation layer going from one to the next. Rather, the same syntax, or one syntax that constructs an operation with REST, can also be expressed equally well through GraphQL. So the core problem that we're trying to solve here, and ultimately what our framework is meant to build around, is that of a monolith. At Airbnb, like with many companies that kind of started as a scrappy Ruby on Rails shop, we ended up with a monolithic Rails application. In fact, we call it monorail. That's the definition of everything you access at Airbnb. Airbnb.com is connecting to a giant Ruby on Rails monorail application. And that's great when you're 5, 10, 50 developers, but it gets just untenable at scale. Our deploys started getting longer and longer. The monolith needed to be broken apart. So we needed some way to go about that. We needed some sort of abstraction layer so that we could break apart the MySQL databases into services. So essentially what we found is that Graphist could sit at that nexus, at that hub between the different ways of connecting to the data stores. So it doesn't matter if you're writing direct Ruby code that instantiates a Graphist operation, or a REST request, or a GraphQL request. Whatever the case, it all reduces to the operation at the end. And that operation has a notion of different resources within it, like a user resource, a listing resource, and these can be backed by different data stores. So it might be an active record or a MySQL table, but we might want to flip it out for a service. So that's the efforts that are being undergone right now at Airbnb, is essentially to start moving those data stores and data warehouses out of one giant MySQL table into individual service-oriented architecture sorts of things. So Graphist actually gives us that abstraction layer where we can flip over a data store, or even do a kind of sampled shadow deploy where we see that we hit both the MySQL table and the service at the same time and make sure that they're both working right, and then finally cut over to the new state of the world. And the important point being that nothing changes on the surface level. The topology for the consumers is unchanged. So they have no notion that the user has just been cut over from a MySQL table to a service. So some of the other things that were kind of important and things that we built into Graphist, or why we wanted to build it, I suppose. Performance, first and foremost, is obviously a paramount concern for anybody building data access or any sort of API. We built in N+1 query solving right into the framework itself, for example, and other sorts of internal optimizations where instead of fetching objects one by one, we can kind of aggregate and coalesce them under the hood. So if we run into 20 requests for users, we can group them all together and throw it out as one request for 20 users. We also thought about things like scale, which is kind of what I was alluding to earlier with breaking into different data stores and services. It's necessary to get off of one giant code base. Graphist also has a whole bunch of monitoring tools built into it that we wanted to think about from the get-go. And this is, a perennial problem, is trying to see where the slowness in your stack is. Something that we are in efforts to solve right now is the fact that any attribute, any field on a resource can be slow for a myriad of different reasons. And it might be provided by some team that another team is consuming. So to have that insight to say that, oh, that request for the listing, the Airbnb listing, was the part that was slow, and I know who to point the finger at, is very important for us. So to have those tools kind of built into the framework itself that give us insight into what attributes or what properties are being slow is a very good benefit. And finally, and perhaps most importantly, is the notion of security, which is also kind of baked into the framework here. So we have what we call policy files, and policies are essentially whitelists of what can be accessed and by who. The notion being that you write a policy once, and it's applied throughout the ecosystem. So my favorite example here is that of a last name. A user's last name is what we would call PII, or personally identifying information. And the definition of who can access that PII should not be repeated. It should not be a concern for each and every developer to have to think about. It should come implicit to the very idea of a user that the last name is guarded by some sort of policy control. So for us, for example, that means that you can only see the last name if you are the same user, or you have an active reservation with that user, one of the other sorts of gates that let you through. But the ultimate user, or the ultimate developer who's using that user, is not someone who wants to think about that access control. The very act of attempting to access last name should trigger that access control. So as long as everybody's playing within the Graphist ecosystem and within this framework, then they get all of those concerns for free instead of having to think about those checks every time they write code. But bringing this back to the kind of GraphQL side of the story here, what we realized was the problem with REST was our notion of how we define the shape of data that comes back. If there's one thing that really bothered us and was really slowing down our development on the API, it was the coupling between front-end and back-end development. So in REST, what we had is this notion of what we called formats. A format is just a name or a string which identifies some array of fields that should come back. So you might have a user format for the user profile, and that format might include the first name, last name, and picture. That's all good and well, but the problem with them is that they're defined on the server. And in being defined on the server, it means that the client developer has to go poke the person around the corner or down the hall to change the server code whenever they want some different response shape back. And that's problematic because of the monolith. Now we have a couple hours to get the code up and reviewed, and we got to merge it, and now we got to deploy it, and now we're waiting on a deploy train, and it might be 24 hours before the client developer can see that new field, and oops, whoops, it wasn't the one I needed, and can you change it again, please? That was a huge cascading problem for us. This notion of having these formats that had this tight coupling between front and back end was just becoming increasingly problematic. So, full disclosure, I mean, we are still essentially using REST today. We are just starting to roll out our first real production GraphQL usage. Even though Graphist now supports it natively as an access paradigm, we're starting to experiment with the very notion of using GraphQL first on our mobile clients. So I'm going to talk a little bit about how we've approached it and what decisions we made in that kind of rollout here. So the first thing that I think is kind of interesting to talk about is schema generation. Schema, obviously the thing that defines your API. GraphQL provides the notion of having a schema that defines your API. One thing that is a little bit different about how we approached our schema is that schema is derived from code. Schema is not something a developer writes, rather the developer writes code. The schema comes out of that code. We do this through reflection or introspection upon the code itself. So Graphist looks at the definitions and figures out what the schema is based upon what the developer wrote. We can even do stuff like AST parsing and whatnot in order to grab out comments and stuff those into the documentation as well. So the whole idea here, and we haven't actually gotten that far yet. We haven't actually done the AST parsing to pull comments into the documentation. But the idea being that let's let the developer think in the way that the developer thinks. They write code, they write comments. The schema, the graphical interface, the documentation, all of this are living tools that immediately come out of the very attempt to write the code itself. And we also have some other cool things that kind of come out of that as well, which is that we actually snapshot the schema with each deploy we do. So every time new code is pushed to production, we take a snapshot of the GraphQL schema that was generated with that push, and we are now able to compare those different versions of the schema over time. And this is really useful if you have an incident, for example, where something causes the mobile apps to crash or site goes down, whatever. You might want to trace back everything that happened. And one tool amongst the toolbox is to be able to see what schema changes have been made to the API between deploys. Actually, I think this is a really interesting opportunity if anybody's looking for a good project to work on. I think something that compared GraphQL schemas and gave you a nice visual representation of what changed over time would be quite interesting. Something that we've kind of thought about as a way to be able to say, like, oh, between that deploy and that deploy, I want a good visual manifestation instead of looking at JSON files, what the differences were. So I think the kind of takeaway there is that an API is really only as good as its documentation. And developers, well, me as a developer, I don't like writing documentation. I'd rather write code. So if the code can form the documentation, that makes everybody's life great. And that's what makes GraphQL special here, is that REST and the rest of the world didn't have this sort of community and tooling surrounding it. Graphical, for example, is a living, breathing sandbox / documentation experience. So, and lastly, I kind of want to talk about the challenges on the horizon and really where we're at right now in terms of rolling out our GraphQL endpoints. The first thing that I want to talk about is query registration and the approach that we're taking towards the native infrastructure, native developers using our GraphQL endpoints. So our native infrastructure team is essentially the foundation of framework builders for our mobile apps, as well as the website. They are building on top of Apollo and essentially creating a Graphist client with just a minimal amount of additions that kind of bake in some of the assumptions we have around pagination and primary keys and caching and some basic ideas like that that play nicely with how Graphist is formulated on the back end. So they're currently working on essentially wrapping the Apollo SDK and building out our Graphist client library that connects to the Graphist backend. But of course, it's all just GraphQL in terms of the syntax under the hood and all that sort of stuff. Just very, very minor additions that were relevant to Graphist-specific concerns here, like I said, pagination. And in so doing, some of the things that we're thinking about, like I said a moment ago, is query registration. So query registration is this notion that instead of sending up the whole giant GraphQL query at once, you send up either a fingerprint or a name of that query. It has a couple advantages. The first is that it means that you send up a smaller payload, so you don't have to send, possibly a multiple megabyte large GraphQL query, but you just send up a small identifier for that query. This also gives you a pretty handy escape hatch on the server side, where if the identifier maps to some query, you can block that identifier, you can change the query itself or fix some sort of problem that might have been wrong with it. So hopefully we never have to use that escape hatch, but it's there should we need it. And it also gives us the ability to do code review on the queries that are actually used in production, because we don't really want to open up any GraphQL query to any client in the wild. we want to be a little bit more methodical about this. We want to actually think about what queries are shipped, because we have a lot of scrapers hitting Airbnb, frankly. There's a lot of people who really want to know about the listings and the availability and all that sort of stuff. And any tool that we put out there for them to get as much data as they can possibly get at once, they will abuse. So query registration is a mechanism by which we can lock down and restrict what things can be gathered from the API at once without allowing for just arbitrary access to a billion things at once. We also have other tools that we've built in to attempt to defend against those sorts of attacks. We have something called Cost Defender, which essentially counts the number of leaves in the JSON tree. A lot of this is very inspired by our early talks with Dan over at Facebook on the way to think about the cost of any given endpoint. So we simply look at the number of leaves on the JSON tree, the number of values at the end, and call that the cost of the response. And we ascribe that cost to the entity making the request. And there's a fixed amount of cost that any entity gets per hour. And should they run up against that threshold, should they deplete their gas tank, if you will, then we throw some sort of friction in their face. Captcha, for example, is a way that they can refill their gas tank and get back to good standing. So as we kind of go about this initial rollout, I think it's even just this week that our native infrastructure teams are just shipping the first GraphQL queries to production. Very exciting times. We are essentially trying to benchmark the whole thing. We are looking at REST and GraphQL requests side by side and making sure that they are indeed just as performant as each other, which they should be. Like I said, it all maps to the same operation under the hood. They're just two different syntaxes for expressing the same thing. But the real exciting part is, as long as these assumptions all hold true, and as long as this goes the way we expect it to and hope it to, then we can start playing with the more advanced features. The way we've approached it so far is that all of the endpoints that were built in Graphist and were REST compliant are innately available in GraphQL. But the way I think about it, at least, is that GraphQL is a superset of that. Instead of just having create, update, delete, you have the ability to introduce arbitrary verbs and arbitrary actions into your ecosystem. And that's where developers can really start having fun. They can start implementing new types of requests and new types of actions to be taken on their resources. And of course, there's all different other great things that we might start looking into, like subscriptions and so on and so forth. But first things first. So that's the basic gist of it. My name's Zane, and this is Geobio. These are our email addresses. And I wanted to open it up to questions. Yeah, right in the back.
Question. You were talking about performance earlier.
Yeah.
And did I catch you right? You're saying you're aggregating requests from multiple users?
So just to recap the question, it was about performance and the notion of aggregating requests. So no, we're not aggregating requests between multiple users. Rather, what we're looking at is the traversal of the object tree as we render the GraphQL response, or even REST response, doesn't really matter. As we walk the tree of objects that we need to return, then we can encounter different requests that are being made. Let's say that there are 20 listings that need be returned. Well, if instead of making the first listing request, then getting to the next listing request, and then to the next listing request, and issuing them one by one, what we would call an n+1 query problem, we instead can use fibers in Ruby, which is essentially a lightweight version of threads. This is something that we're actually working on right now, actually, and block that fiber and say, we know this is about to call out to a data store, and we're going to block that fiber and wait and wait for all fibers to be blocked. Once all of them are blocked, we can say, you know what? There was actually 20 requests for listings. There wasn't one request for a listing. Now we can fetch all of those 20 listings at once. So we solve that n+1 query problem innately to the system, as opposed to requiring a developer to think about this.
Well, it's sort of kind of the same thing. Sounds like you're
Yeah. I mean, we're putting the requests on one bus, but we're packing that bus as full as it can be instead of shipping out 20 buses.
That's pretty interesting.
Yeah.
Secondly, is you said you're doing that the app is offline, or offline is important.
Yeah. So the question was about the notion of offline. That was really meant to set the context in terms of like why Airbnb, in the beginning, it was very much a website. Airbnb was Airbnb.com. Like the mobile app did not arise. The iPhone wasn't even a thing when Airbnb launched. So the transition that we went through was to realize that mobile is the much more important touch point. We are more of an offline experience than an online experience. And increasingly, mobile was deriving the definition of our product. And the API was becoming the more canonical way of accessing data than the website itself. And it made sense then for that API ecosystem to evolve into the abstract data access layer.
So, offline of the client is a
Mm.
challenge.
Ah.
Data synchronization. And I'm challenged getting a sense of how that's even done with GraphQL. Your client is the Graphist client.
Yeah.
So, do you guys, to what degree do you manage offline data synchronization? How do you do it?
Yeah, so the question is about offline data synchronization and really caching, I suppose, when you get right down to it. And that's something that our native infrastructure teams are working on right now in conjunction with us. You know, we are kind of more the back-end team here. But that being said, the approach that they're taking is essentially to decompose the response with the knowledge of a primary key on any given object. The ID of a user is the thing that allows you to cache that user. And they can populate their caches with whatever attributes come back. And what they're aiming for is the ability to recompose objects on the fly. So should they need to fulfill a request for from the cache, they can do that even if the attributes came back from multiple different responses. So the idea being that if there was one request for a user that had the first name, another request that had the last name, but then you issue a third request that hits the cache and it wants both the first and last name, it should be able to successfully fulfill that request. So that's the aspiration behind it. I don't want to put words in their mouth or make claims about their progress beforehand, but I think that's kind of the general vision of how we approach that notion of caching. But most importantly, they're thinking about it as a primary concern. There's a prioritization in the cache, and we want that data to be immediately available as much as possible, to the extent that, you know, if you open up your app and you're in a no reception area, you should absolutely have access to your message threads and to your check-in instructions and all that sort of stuff.
Can you, which is the goal, also to be able to mutate and take actions that if you're offline, be able to take them. I want to reserve this, but you're offline and it holds everything to make that mutation.
That's an interesting idea. I don't think we've really talked about that so much so far. I think the idea of, you know, making a reservation, like it's essentially a deferred request at that point, and I'd have to think about that more if there's any real benefit to having like a deferred request there that just gets sent off when you come online. Maybe it's something that we might want to start thinking about. Yeah.
Basically, it's your queryable information also actionable.
Yeah, is it mutatable? Is the cache mutable? Not something that we've approached thus far. One thought we have had is the notion of cache warming remotely. I think this would be a really interesting opportunity, is to use, for example, a silent push notification in order to populate that cache with a message, for example. So even if the app is closed, if the iOS app is closed, you might imagine a world where the push notification that sent you the message from the host actually included the full contents of that message, and it warmed the cache with it. So that then later you opened up the app, even though there's no internet, and you never opened the app with internet, it still warms the cache and you can see the message thread. I think that's kind of one of the more magical, visionary things that I would love to see happen, but again, first things first. Yeah, another question.
So a question about your N+1 stuff.
Yeah.
Was that interacting with Active Record directly? Like you said, you were using finders to figure out, hey, we're about to hit the DB, so instead of yield the file or lock the file or whatever, and aggregate a bunch of them. Is that like a layer around Active Record? Or can you maybe elaborate a little bit on the detail there?
Yeah, so again, full disclosure, this is very much an active project right now.
Yeah.
So do you want to talk about that at all? Because it's actually something Geobio's working a bit on.
Sure. So one way we're doing it is that whenever you want to load something, for example, let's say that a listing has a user. And so when a developer is writing the code to access the user, they would sort of write how to load that user. And so next time you call listing.user, it doesn't actually fetch it immediately. Rather, it creates this deferred load, or this sort of like a URL. And then the fiber would have that URL. It would block until all the fibers are blocked, and then try and aggregate all of the same URL, for example, all the same URL for a user, and then load that all at once. So it does require a bit of work by the developers to make sure that every field or attribute is written in that way, but then the framework would take care of the rest of the aggregation fibers and loading.
Cool, I see. So is that like significantly different from Shopify's batch loading thing? Look at that at all?
I have not looked at that. I can build a little bit on what Geobio just said there. There's one thing that we standardized on here is the notion that each resource is responsible for defining its own what we call data loading strategies.
Yeah.
And that means that a user never instantiates a listing. Rather, it says to the listing, I have these set of parameters, instantiate yourself given these parameters. And then Graphist, the resource layer, is a wrapper around whatever data store is below it. So whoever implemented that listing or user is responsible for responding to that request for that type or those inputs for data loading. And because we sit at the boundary in the framework level between those two resources, we have the opportunity to defer at that point when that request is crossing the boundary between resources. Yeah?
So for your Graphist client, are you porting to native iOS, native Android, and web?
Yeah, so my understanding from the native infrastructure teams, again, trying not to put words in their mouth, is that they're, oh, I'm sorry, right. Are we porting between the different platforms? As far as I understand it, they're just building on the tools that exist there so far. So if I understand correctly, Apollo has a native SDK for Android and iOS, and also, of course, the web library, and we're just kind of building wrappers around them that add our additional business concerns. So I don't think there's any porting going on, per se.
Does Apollo have an SDK for iOS? Does anyone know for sure? I thought everything was JavaScript. Okay.
No question or answers in the room? Yeah?
Yeah, I got one more question. So with your security stuff, the policy stuff's pretty cool, and I imagine that you can have I guess you said that you can check permission at a field level on each object or whatever. Does that mean then that your GraphQL schema has a lot of nullable fields in it because maybe the user doesn't have permission to see something? Or do you handle that in a different way?
Interesting. So the question is about policy checking and the notion of how we gate access control, specifically with regards to the schema, yeah?
Right. It feels a little unsatisfying to have an object where everything's nullable because maybe someone doesn't have permission to it.
Mm-hmm.
Because then the client is now responsible for checking if this thing is present all the time.
Yeah, so the question of do policies affect what you see in the schema is actually a discussion that we're having with our security teams, literally right now. There's an email thread between me and our security teams of, is it important for us to lock down the schema definitions for clients? Is that an attack vector that exists? Is it a bad thing if somebody knows that this field is even accessible or exists in the API? Because certainly there are endpoints that are by design admin only. And once some third party sees our schema, is it a bad thing that they know about that endpoint? Or how do we represent it to them if it's not something that they can access? Not a solved question at the moment, but I think we're kind of agreeing that if a developer writes a schema that has an attack vector in it and exposes some sensitive information about the stack, that's probably a bad thing. Like, you have to assume that schemas are going to become public knowledge at some point or another. Like, people are going to know your API in some way, shape, or form. So if you're building your security under the assumption that nobody's going to know that it exists, that's just security through obfuscation, or security through obscurity, not true security.
Sir, quick follow-up.
Yeah.
So if somebody requests some data from schema they don't have access to, do you just straight up forbid the full request, or do you return a partial piece of data?
If somebody requests access to data to which they do not have access,
Like, it's a mix of data that they do and don't have access to.
yeah. So our current approach is that we do blow up the entire request. This was by design in the RESTful world, and that was largely in a place where there was only one operation per request. It made perfect sense. You do not want to continue down the road of continuing that operation. Like, it should just explode and throw an exception, and the whole thing should end. But I can see an argument, and I think we are starting to agree, that if you have, say, multiple top-level function calls or multiple top queries inside a GraphQL request, well, maybe one of them threw an exception, and it should end, but maybe the other two should proceed. And I think that's reasonable. Still trying to wrap our head around the possible consequences of that, because what if there was a dependency between the first and second one? I don't think it's so much a problem with queries, but mutations might be bad. If you expected the first to succeed and then the second relies upon that success, you could find yourself in a bad state. And we very quickly end up in the realm of transactionality and rollbacks and all that sort of stuff. So I think that might be kind of dangerous territory. But that's just, off the cuff.
Awesome. Thanks, Zane
Yeah.
and Geobio.